All right, so looking at the very back for Friday, September 23rd, looking at the notes. Now, what this is saying is that we're trying to find the limit of delta x approaching 0 of this function here. This is a little bit more complicated than what we've been doing. We have to work back and forth between these two. We have our problem we're trying to do, and this is the function we're using to do it with. Okay? So I'm going to start by just writing the limit as delta x approaches 0. This is what I'm trying to compute for this function. So I've rewritten this. So it's like I can forget about that now. Now I have to do f of x plus delta x. So I look at my function. To find f of x plus delta x, wherever I have an x, I'm going to have to replace that x with x plus delta x. So I have a 5. My x gets replaced with x plus delta x. And then I have minus 3. Look at that, guys. This is 5x minus 3. Do you see how that's what it is? It's just that the x got replaced with x plus delta x. I've done this part. So right now, I've done this part, and I've done this part. So now I have a subtraction symbol. So I'm going to write that. And now I have to do minus f of x. Well, what is f of x? 5x minus 3. And then I just keep going with the problem, and I have over delta x. So now I'm ready to simplify. So now I'm no longer having to look at that problem back up there. I'm just ready to do this problem. See, now we're actually having to add on one step, and that's setting up the problem. So to simplify this, I distribute. I get 5x plus 5 delta x minus 3 minus 5x plus 3. Remember, our whole goal is to be able to plug in 0 for delta x and not get 0 over 0. So we're going to see if that happens after we simplify. So I have 5x minus 5x, that's 0. I have negative 3 plus 3, that's 0. So now I have this problem. The limit as delta x approaches 0 of 5 delta x over delta x. I'm not allowed to do any dividing until I just have factors. Well, these are now factors. 5 times delta x over delta x. These cancel, and now my answer is just 5. Okay? So I got through the whole problem then. I finished up that and that. So now let's look at the next one. Yes, Brandon. Yep. I'm doing this problem for this function. So I had to do this problem. I rewrite limit of delta x approaching 0. Then I had to do this part of it. So f of x plus delta x would mean wherever I have that x, I had to replace that x with x plus delta x. So I just had this 5 times x plus delta x minus 3. Then I had to do minus f of x, and f of x was 5x minus 3. And then I just had to write the delta x. I'm going to go really slow with the first step on this one. Let's see if that helps. Okay. Who else is lost? Anybody else lost? Okay. Because this is a limit formula. When we get into derivatives, this is going to be a formula that we're going to use over and over. Right now, it really doesn't have a lot of meaning to it, but it's actually the definition of the derivative. So we are using the definition of a derivative to find these limit values, because we have to understand the function notation before we can actually apply the derivative. That's the reason why we're doing it, and now we just kind of need to try to do it. Okay. Watch the first step really closely. This is my problem, right up here. I'm going to use a different color because I'm going to mark out as I go. This is our problem right here. So I'm writing my problem. It's the limit as delta x approaches 0. I have to do the next step. I just did this. I rewrote that. I'm done with that part of it. I go to the next step. F of x plus delta x. Here's my f function. Here's my x. So what is that x going to get replaced with? So now I'm going to have 3 over x plus delta x. That's what this part of it is right here. Done with that. That's what this was. Now I have to do minus f of x. What is f of x? 3 over x. All over, look at your problem again, delta x. When you sit in that college calculus class next year, this is going to be the first thing that you're going to start with, are these kind of limits. So you really need to understand that first step. Do you think you could recreate the first step now? I think you can. Yes. All right, so now we have to finish the problem once we have the setup. That very first step is the hardest part on these. This is now a problem similar to those that we've done. We have to multiply through by that common denominator of x times x plus delta x. Questions on why I'm doing that? So now I'm going to have to distribute. So I'm going to have to multiply the first times the first. When I do this, I have 3x, x plus delta x over x plus delta x. So what's going to happen there? Those all cancel, right? So now I've got the limit as delta x approaches 0 of just 3x. Done with this one. Forget about that one. Now I have to distribute to this one. What's going to cancel there? The x. So I have minus 3 times x plus delta x. Am I going to multiply out the denominator? No. I've said this over and over. Only the part that's complicated. You want to make it simpler. This is already simple. If I multiply it out, I'm going to make it more difficult to work with. So there we go. So now it's just a matter of simplifying. So my numerator is going to be 3x minus 3x minus 3 delta x. All over that. So I'm just going to rewrite it as I simplify. I've got the limit as delta x approaches 0. 3x minus 3x is 0. So I'm going to have negative 3x over my denominator. Sorry, negative 3 delta x. So negative 3 delta x over my denominator. And so now what is going to cancel out, guys? Delta x. So this delta x goes away with this delta x. And so now I'm going to have negative 3, and now is where I can finally drop this limit, because I'm going to plug in 0 for delta x. If we plug in 0 for delta x, we're just left with x times x. What's that going to be? X squared. And that's our answer. Like I said, right now we're just learning about limits. When we start with derivatives, that's going to have meaning to it. It's going to be telling us the slope of the tangent to the curve. Questions on that? Alright, so that's the hardest part. That's the only thing that's new for today. Now let's flip back to the older stuff. This is all just kind of review. Okay, we're going to state the 3 methods which can be used to evaluate limits. There are 3 methods. The first one's numerical. Numerical is just plug in. If we plug in and we get 0 over 0, that means we're going to have to do more work. If we plug in and we get non-zero, over 0, that's going to mean that the limit does not exist. So if we get 0 over 0, we have to do more work. If we get 5 over 0, the limit doesn't exist. Negative 8 over 0, the limit does not exist. Okay, so if this happens, what's the more work we can do? Well, we can do an analytical method. An analytical method would just be algebra. So that's where we are going to factor, or we're going to multiply out, or do something like that. The other thing we can do is we can graph on the calculator. That might be a helpful thing to do. This is the better method, though, if we can do it, because it's going to give us the most exact answer. The graphing on the calculator can help us support our answer, but a lot of times it's not going to be exact enough. All right, so I want you to do number 1. I want you to just plug in your 4 and tell me what happens. Jacob, what do we get? What does that mean? Right. Limit does not exist. Okay. Let's go to the second one now. We plug in 2. 2 to the third is 8, minus 8 is 0. 2 minus 2 is 0. What does that mean, Brittany? Good. We're going to use analytical. We're going to use some algebra. We have 2 methods that we can use for this problem. One of them is factoring. The other one is synthetic division. We'll go with you, Mary Beth. Which one would you do? Synthetic, okay. So to do synthetic, I set the denominator equal to 0, and I get 2. And then I'm going to go 1, 0, 0, negative 8. I bring this down, and I get 1. 2 times 1 is 2. I add. 2 times 2 is 4. I add. 2 times 4 is 8. I add. So this was x to the third, so that means after I divide, I'm left with x squared plus 2x plus 4. So now I'm taking the limit of that. So now if I plug in the number 2, I'm going to have 2 squared plus 4 plus 4. What's that going to give us? Four plus 4, guys. 12. Okay? If you needed to, you can do the factoring. I kind of like the synthetic division. I think it's a little bit quicker. Plus, you don't have to memorize the factoring formula. If you do, then you can look back at yesterday's notes for the factoring formula. All right, what do we do if we have a radical? What do we do, Maddie? If we have a radical, multiply by the conjugate. So I'm going to do the conjugate here. So I'm going to have radical x plus 9 plus 3. Radical x plus 9 plus 3. We do that on the top and on the bottom. I'm trying to plug in 0 for x. I'm not going to get it to work. I'm going to get 0 over 0, but now I'm going to distribute this out. A radical times a radical, the radical just goes away and we have x plus 9. When we do the conjugate, what happens with the outers and inners, everybody? 0. Negative 3 times positive 3 is going to be negative 9. I do not multiply out the denominator. It's going to get more complicated if I do. Here's what we have. Well, now we're going to have 9 minus 9. That's going to be 0. So we have x over x times this kind of complicated looking function. So what's going to happen now, Anna? What happened? What can we do? Right? And so then we're left with a 1. And now we're going to plug in 0 for x. So I'm going to have 1 over 0 plus 9 is just going to be 9. The square root is going to be 3. And there we go. Okay. Everybody do number 4 on your own. Think of the first thing that you should always do. Kelsey, what'd you get? Okay. You don't have it yet? Oh, okay, I thought you did. Let's see. What did you get, Taylor? 6? Did anybody get 6? Maddie got 6? Everybody agree 6? That's not what the last class got. Let's see here. Yeah, I think we get 0. Let's see. 3 times 1 squared is 1, minus 5 times 1 is 5, plus 2. So it's going to be 3 minus 5, that's negative 2, plus 2, that's going to be 0. Did you guys have a plus here, or?
Oh, no, that was, I got like after I factored.
You don't need to factor it. You just need to substitute in the number. See, we only have to do factoring if plugging in the number gives us 0 over 0. So you just want to go ahead and substitute in the number. All right, let's look at this one. Number 5, the first thing we do is we plug in 0. And I'm going to get 2 minus x squared minus 2 minus x squared. That's going to be 0. I get 0 over 0. What is the more work that we should do on this kind of a problem? Sean, do you know? Yeah, just multiply it all out, right? So just do the algebra, like limit, delta x approaches 0. We have a 2 minus, now here's where it gets a little tricky. We have to square this x plus delta x. Can somebody do that for me? Do you know what we're going to get if you square that out? Like if you FOIL it out, x plus delta x times x plus delta x. Keep going. Plus 2x delta x plus, good. So that's that part, and then we have to do minus 2 plus x squared, because I had to distribute the negative. Now, a lot of people miss this kind of problem because they forget to distribute this negative. See, they're pretty good about distributing that last one, but you also have to multiply this one. So we have to still do that. So we're going to have 2 minus x squared minus 2x delta x minus delta x squared minus 2 plus x squared. It's a lot of writing. But hopefully a lot of things will cancel out at this point. What's one thing that'll go away? 2 minus 2. What else? Negative x squared, positive x squared. So now we're left with just these two terms. What can I factor out of those two terms? What do they have in common? Delta x. So I'm going to take out a delta x, and I'm left with negative 2x minus delta x over delta x. And then what can we do? Cancel the delta x's, and that's where the problem was. That's why we kept getting 0 over 0. So now we can plug in the delta x being 0, and what's our final answer then? Just negative 2x. All right. Try 6 and 7 on your own now. You should remember those. Those are the special limits. If you don't remember those special limits, just flip over. They're right here at the top of this other page. You be trying it on your own. If you get stuck, you can look up here. So were you able to get 5 and 0 on your own? Very good. Alright, let's come down here to the bottom. Okay, so we're graphing this function of x squared plus 4 only when x is not equal to 1. If x is equal to 1, then we're going to be plotting the point -3. So I'm going to plot this. This is a parabola shifted what? Of 4. So it's going to look like this. But it's going to have a little hole in the graph at 1. If I plug back in 1 squared plus 4 is 5. So at 1, 5, there's going to be a little hole in the graph right there. And when x does equal 1, we're going to be plotting -3. So there's the way the graph looks. So this is asking us for the limit as x approaches 2. I might not want to use my graph because unless I graph this perfectly, I'm not going to be able to tell. Where am I going to plug the 2 in then? Right here, right? What are we going to get if we plug in 2? 8. That's our limit there. The limit as x approaches 1. This has a little bit different thing happening. So here we are. We're traveling along this parabola. In order to have a limit, the red and the blue have to be approaching the same y value. What's the y value they're approaching there? 5, yes. The answer to this, what do you think a lot of people would put the answer to that as being? -3, yes, because of that. But that's not the trend. It's like, where is the y value going to as we're traveling along these paths? You can think of it driving. A red car and a blue car driving along this parabola. Where do they meet? That's the limit. That's just a pothole. It's like it's been thrown off the side of the road or something. Not like that's important. Find g of 1. This now means something different. This isn't a limit. This is saying when x is 1, what specifically is y? What's the answer to this, everybody? -3. Don't miss those on your quiz, guys. Understand that concept. Look back at this again. Make sure you've got it down. Okay, and then this last thing, we did these. We understood how to work these. It looks complicated, but it's really not at all. It's just going to be 3 times, what's f of x, everybody? 6 plus g of x is limit. Its limit is -1/2. So we have 18 minus 1/2, that's 17.5. This one is the same thing. Even though it looks complicated, it's just going to be -3 times the limit of f of x, which was 6, divided by 2 times the limit of g of x as x approaches c, and that was -1/2. So this is going to be -18 divided by -1, so that one should be 18. Okay? Any questions? So make sure you do the assignment on your assignment sheet for Friday. It's all odd problems. Shouldn't be too bad. Check your answers as you go.